So 2.4 is all about solving proofs. We are just going to take our proofs, and what you can see from a proof, and it is based on a table. Okay. Each proof has two different columns or two different things. One of them is called a statement column, and one of them is called a reason column. Most of the time in this class, I will give you the statement column. Not all of it, but most of it. Okay. There will be some times you have to fill some things in. So if you notice, there is something that has to be filled in right here. So there are some things that have to be filled in the statement column. Now in this column or in this setting for 2.4, most of the time, I'm going to make you kind of write the statement column, but as you work your way through geometry, that statement column is going to get more filled in as we go. Okay. The whole way that a truth table or a proof works, is this column right here is meant for you to do your work, to be able to figure out where you're going. You're given something at the beginning, and then your job is to map out how to get to the end. Because if you notice, at the very end, we should be solving something, right? The whole idea is that we're solving. This thing right here is why. Why were you able to do that? Why were you able to fill that information in? Why were you able to do this stuff? Okay? So your job is to figure out why you're able to make those steps. Okay? So if you were to solve this thing, if you were to solve this first equation, what would you get? How would you do it? How would you solve negative 2x equals 4?
You would plus 2.
Nope.
You would divide by
You would divide by negative 2, right? So we would divide by negative 2. So then I would end up with x equals negative 2, right? Now, what was the reason that how did we solve that? What did we do?
We divide.
We divided. So this would actually be called the division property.
Did I use possible last year?
You did. So that's why we start out with proofs in a very, very easy way. Okay? So, proofs start out with a statement. Your job is to take that statement and solve it. Okay? You are supposed to get from the beginning to the end and fill in all the stuff in the middle. Okay? This reason right here, number one, is always, no matter what, no questions asked, no matter what, is always the word given. No matter what, in a proof, the first reason, number one on the right side, will always be given, period. No matter what. Number one in the reason on the right side will always be given. I have no idea what this problem on the right says right now, but this thing right here will be given. No clue what the left side is at all. No matter what, if you write the word given in number one on the top right, you will get it right. Okay? That should be a point that every single person gets on every single test for the rest of the time until you die. Yes?
And what are you supposed to turn a proof into? Like the statement?
So this side is the statements.
No, you said the proof starts out with a statement, and your job is to take that statement and turn it into.
You're supposed to just solve it. So your job is to take that statement and then solve it at the end. Yep. So these are the columns that I was talking about. Your left columns are your statements and your right columns are your reasons. Okay? So what you have to do is you have to be able to provide the steps and then you have to provide the reasons. Okay? A proof is essentially a set of directions. That's what it really is. A proof is something where they give you a starting point and they give you an ending point and you fill in all of the directions on how you were able to go from step to step to step to step to step to get there. I always like to think about a proof kind of as like directions when you're going somewhere. So like if I told you all to just like, if you had to explain to someone who wasn't from here to go to 7-Eleven, do you all know where 7-Eleven is from here?
Yeah.
If I told you to go to 7-Eleven, could you get there very easily? Yeah, but if someone from Japan walked into the building and I said, okay, hey, can you get me a pop from 7-Eleven? And they're sitting there going, I don't know what that means. Would I just say, okay, just go get in your car and go to 7-Eleven? Now, obviously, what would they have to do? They'd probably have to type it in their phone and find the directions, right? A proof is like that set of directions that gets you from point A to point B, okay? So that's what that is. Okay, the next thing for this problem on the right, the next thing that you have to do with your proofs is this statement right here is what you're using to work with. Whatever you are given at the beginning of a problem goes in number one. So this would be x plus 9 equals 2. So the first column of your proof, or the first row of your proof, should be the easiest thing that you have ever done in a math class in your whole life. You rewrite whatever is given to you right here in number 1, and you write the word given in number 1. Okay? Should be the easiest thing you've ever done. Number 1 is what you are given on the top left. Number 1 on the right is the word given. Okay? Now, what do I do to solve for x here? Subtract 9. So I'm going to subtract 9 from both sides, so that I'm left with x equals -7. What was the reason I got from this step to this step?
The number one number, subtraction.
I did use the subtraction part. Okay? So I used the subtraction part. Okay? This is what proofs look like. Okay? They're starting off as very simple, very basic algebra problems, because that's the easiest thing that we can use in math right now. Because all of you know how to solve a 1, 2, and 3 step equation. But we're just going to take that step and go step by step by step by step and move. Okay? So now we will go through these properties just in case you don't remember them. So in case you don't remember all of these, that's fine. If you do remember all of these, that's great. But if you don't remember them, that's okay. All right. So addition property means that you can add the same thing to each side of an equation. So the addition property means that you can add the same thing to each side of an equation. Right? The addition property means that if I have two things that are already equal, and I add the same thing to both sides of an equation, I am able to do that. So I'm going to put plus c and plus c. If I add the same thing to both sides of an equation, that means that I'm fine. Everything is good. Okay? The subtraction property is you can subtract the same thing from both sides of an equation. Oops, that shouldn't be the same thing. That's a bad word right here. Bad wording right there. Okay, so this is each side. I think that's what I was saying over and over. I just wrote the wrong thing. You can add the same thing to each side of an equation. And then in this one, you can subtract the same thing from each side of an equation. So that would be like a minus c and a minus c. I'm sure you can figure out multiplication and division right now on your own. But you can multiply both sides of an equation by the same thing. So like if I have a times c and b times c. And then finally the last one is you can divide each side of an equation by the same thing, so a divided by c and b divided by c. Now basically that's just what you learn in algebra, right? If you want to solve or get rid of something on one side, you just do the same thing to both sides, right? So you're just doing the same thing to both sides of the equation. With the bottom left on the distributive property, if I have a times parentheses b plus c, what does that turn into? What does a parentheses b plus c turn into? Do you remember?
A, B, H, C.
Not quite. Close. I'm looking for one little thing there. Because you're right. I mean, technically you're right, but we're still missing something. There is a plus sign in between. So remember that number out front, or that thing out front, gets multiplied through to each of the things on the inside. So if I have a times b plus c, then it's going to be a times b, and then a times c. But you're going to keep the sign that was in the middle. Okay, simplifying means that you can simplify or combine the terms on the same side of an equation. And what I mean by this is if it looks like this. Notice how on the left side of the equation, we are dealing with only the left side of the equation here. Notice how I could add 2x and x together, right? Is that legal for me to do? Could I combine 2x and 1x together?
Yes.
Yes. Would I subtract 2x from each side of the equation in this problem right here?
No.
No, I would not. not until I've combined them. This is what simplify is. Simplify means that I'm going to combine my two statements, so I would have 2x plus x, which would be 3x plus 3 equals 5. This is what simplification looks like. So that's what the simplify step looks like. Okay? Any questions with what you see for simplify? Because that's one of the ones that gets people a lot. That's what simplify is. The reflexive property is another easy one. If at any point you see A equals A, or B equals B, or C equals C, or AB equals AB, or CD equals CD, or ABC equals ABC. If at any point you see something that's just repeated, then you use the words reflexive property. That should be another one of those giveaways in proofs, okay? If you see something in a statement column where it says 10 equals 10, AB equals AB, angle ABC equals angle ABC. If you see something that repeats itself, you put the word reflexive and move on, okay? The symmetric property means if A equals B and B equals A, if for some reason you have to flip something, that's the symmetric property. So you know what, do you guys prefer seeing something that looks like x equals 2, or do you prefer when it says 2 equals x? We would almost always prefer that it says x equals 2. So if you end up solving your equation and it looks like this, then all you have to do for your next step is do x equals 2 and call it the symmetric property. Okay, that is what the symmetric property is. And then for substitution, if you know that two things are equal, then you can plug that one thing in for something else. So I know that if A and B are equal to each other, then I can plug B in for every time I see A. It's kind of like if I had something like this. If I said that x plus 2, and I know a while later I find out that x equals 2, is it possible for me to go back into my equation and plug 2 in for x? And then find out that 2 plus 2 equals 4? That's what substitution is. Substitution is when you have something, and then you just plug something else back into it to solve. Any questions on these definitions? These are all definitions that you have seen at some point in your life, so this should not be something that's brand new. It might be something that's a little bit challenging, I'm not sure, but it's something that is not brand new. You have seen this before. So now let's work through several of these proofs together. Every once in a while, not every single time, but every once in a while in geometry, I will give you something called a reason bank. Okay? This reason bank is really, really nice because each one of these, there are 5 things, each one of these 5 things would go into one of these spots. Okay? Now notice down here, I'm not giving you reason banks. So since I'm not giving you reason banks, that's something that you would have to come up with the reasons on your own. So this is something where if I find out that we're really struggling with proofs, I might give you a reason bank like this. Okay? So if we're really, really struggling with proofs, this might be something that I give you. We'll see that. Yeah?
So for the 7x and all that, like right below what we're doing, would number 1 always be given, you said?
Number 1 is always given no matter what, no questions asked.
And so if number 1's given, and then number 2 would be distributed, right?
It would be. So let's work through it together. We're actually going to go through that. But yes.
Just try it on our own.
But yes, you are doing good. Oh, you want to try it on your own first?
Yeah, just
All right, go for it.
on our own.
Go for it.
Yeah.
Okay, so try it. See what you get, and then we'll go through it together. All right, so as we said, the first step is always given, right? First step is always given. So that takes care of the easy one. First step is always given. Now, remember, we are always basically asking how we went from the first step to the next step. So basically, how did we get to step 2? What did we do in equation 1 that got us to equation 2? Well, we distributed, right? Because we took 7x times, or 7 times x and 7 times 11, which created these two numbers, right? So we took these two things up here and multiplied them to get 7x and 77. We distributed up here. So that's how we got step 2. That's how we got to step 2, right? We distributed. So once you distributed, that got you there. So that takes care of this one. So now, the next question is, how do we get from step 2 to step 3? What did we do in step 2 to get to step 3?
Subtract.
What did we subtract?
12x.
We subtracted 12x, right? Now, this might not be the way that you decided to solve it, but this is just the way that we went through it. Okay, we're saying that every person, if they solved it like this, this is what their proof would look like. So we subtracted 12x from each side to end up with negative 5x. And then the negative 77 and the negative 122 stayed the same, so this is the subtraction problem. That takes care of that. Okay? Now, how do we get from step 3 to step 4?
We added 77.
We added 77, right? So we are just describing what we're doing every step. This is the addition problem. Okay? So that's addition. Okay? So that takes care of this one. Now, obviously, the last one is going to be division because that's what's left. But how would we solve to get from here to here? What would you do? You divide by negative 5, right? So then we would be left with x equals 9, and the way that we got there was division.
I don't want the next one.
All right, so that's how this works. Now, this was a very straightforward example. Obviously, the examples can get more complex and complicated. And obviously, this is it kind of runs hand in hand with your ability to do algebra, right? If you have rougher algebra skills, this is going to be a little bit tougher. If you are really, really good at algebra skills, this is going to be a little bit easier. But I think everything on this paper, I went through it and created it based on the fact that I think you all can solve or do all of the stuff that we did. Okay? So let's run through the next one. Notice how this one's a little bit different, right? This one's a little bit different because I'm actually giving you a little bit more, or a little bit less information on the left and a little bit more information on the right, right? So I'm giving you a little less information on the left. You actually have to come up with that. And then a little more information on the right. So over on the right, I'm telling you what I want you to do. And on the left, you have to figure out what that step means. Okay? Now, first step, this is the easiest step. All you do is rewrite it and write the word given. So right now, I'm telling you right now on a homework quiz, this would be a 1, 2, 3, 4, 5, 6, 7 point homework quiz. And you would have already gotten 2 out of 7 points if you did this. Okay? Now that's not the world's best grade, but you would have gotten a 2 out of 7 already. Yeah, go ahead.
Why do I have to show my work for like 3, 4, and 5? Because I know the 1, 2, like I know the properties for that without showing my work. I only had to do number 1, 2, the rest of the year.
Okay, so the big idea, Blake, that you have to understand here, because you're not wrong. You don't really have to show your work to get the answer. I get that. But the whole point of a proof is not getting the answer. The whole point of a proof is being able to explain how you got from the beginning to the end. Okay? That's the point of a proof. The whole point of a proof is being able to be given something and then show me how you worked through it and then got to the end. Okay? So the answer is important. But what you need to understand is you have to be able to get your way through from beginning to end. You have to be able to explain your thought process. Proofs are about explaining thinking, not about getting a final answer. You're not going to believe me, but your proofs, when you actually get them in geometry, I am going to give you the statement. I am actually going to give you the answer on that question. There's going to be a spot that says given, and then there's going to be a spot that says proof. So it'll say given, and then it will say proof. I am going to give you your answer, and I'm going to give you your given, and then I'm going to give you the answer. You have to fill in the dots between the two. So actually, I would argue that the most important part about a proof is this. That is the most important part of what we're doing. Okay? See it again?
Exactly the most important part.
This is the most important part. Yep. Great. All right. So let's work our way through this and talk about it and see what we come up with. Now, obviously, there's no reason bank, but you kind of have a big reason bank right up at the top of this thing, right? All those vocab words, those are the things that you can use in a reason bank. So, how did I go from step 1 to step 2?
Distributed.
I distributed, right? So I have the distributive property. Okay? Now, it tells me that I want to use the addition property. What could I do to use the addition property? Go ahead, Mason.
So you would add 6.
Okay, so Mason is saying we can add 6 to both sides. Is that the addition property? Did we just use the addition property? Yes, we added, right? Yes, there is another thing you could have done, Blake, but we didn't choose to do that one. So you could have added 3x if you wanted to. It won't change your answer. Will not change your answer. So we had plus 6 on each side, so it's going to be, our new step is going to be 3x, negative 3x. We added 6 to both sides, so we're going to get equals 2x plus 10. That's how that step was going to look. So now, the next thing it tells me to do is I have to use the subtraction property. What am I going to do? What am I going to subtract to help me solve this? Go ahead. I'm going to subtract 2x from both sides. Yep. So then I'm going to get negative 3 minus 2 is going to be negative 5x equals 10. And that's how we use the subtraction property. Now, how do I solve for x right now? Go ahead, Mason. Divide by negative 5, so I'm going to get x equals negative 2. And the way that you did that, you said the word divide to me, so we used division. Yeah.
So the first one's given, and you would just, on the right side, you just say what you use, right?
Correct.
That's simple enough.
Hope so. All right. So, those are all the examples that we have time for. Tomorrow is just going to be a big practice day. Okay. So what I want you to do today is I want you to try to finish the front of this page. Okay, just the front. There are only like 3 questions left, or 3 proofs left. I want you to try the front of this, and then tomorrow we are going to run into more examples and go through more examples together. Okay. So that's what I want you to do. Finish the front of the page. Once you get done with the front of the page, then we will talk about it more tomorrow.